Welcome to our half-angle formulas 1 video. Let's take a look at our example. Use a half-angle formula to evaluate the expression below, sine of pi over 4. Looking at our half-angle formulas, one realizes that the one that involves sine is the first one, so we're going to use that particular formula. Now notice that the input here for sine happens to be theta over 2, whereas here in our expression is pi over 4. So let's go ahead and match them up. Formally, we can say the following. Let theta over 2 equals pi over 4. Now, we need to solve for theta, so let's go ahead and rewrite this equation. So we have theta over 2 is equal to pi over 4. And let's go ahead and multiply by 2 on both sides of the equation to isolate the theta. The 2's here cancel, so you get that theta is equal to 2 times pi over 4. Now, let's go ahead and divide both numerator and denominator by 2. So we get an equivalent fraction in the form pi over 2. So theta happens to be pi over 2. Now we can actually try to evaluate sine of pi over 4. However, before we actually do the evaluation, we need to determine whether the square root we're going to use is positive or negative. To do so, let's analyze the angle. Pi over 4 happens to be on quadrant 1. Let's go ahead and see it on the unit circle. Here's where pi over 4 is. So, in this particular case, we ask ourselves the question, is sine positive or negative on quadrant 1? Since all the trig functions are positive in quadrant 1, we can say that we're going to take the positive square root. So we take the positive square root of 1 minus cosine of theta, but cosine of theta here will be cosine of pi over 2 all over 2. So rewriting this in the following format, we get that sine of pi over 4 is equal to the square root of 1 minus cosine of pi over 2. So let's go ahead and come to the unit circle. Here's pi over 2. And cosine happens to be associated with your x-coordinate, which is 0 in this case. So we have 1 minus 0 over 2. Now this is simply the square root of 1 over 2 because 1 minus 0 is 1. And using the properties of radicals, this can be rewritten as the square root of 1 over the square root of 2. The square root of 1 is 1, and we have that the square root of 2 is irrational, so we leave it like that for now. However, since the square root of 2 happens to be in the denominator, we need to rationalize the denominator. How do we do that? Well, we simply multiply by 1 in the form square root of 2 over square root of 2. And this now becomes 1 times square root of 2, so we get square root of 2, and square root of 2 times square root of 2 becomes the square root of 4, which happens to be square root of 2 over the square root of 4, which is 2. So we can say, therefore, that sine of pi over 4 is equal to the square root of 2 over 2. And this particular example concludes our video on half-angle formulas part 1. Thank you for watching and have a wonderful day.